So we continue from yesterday where we stopped, from the previous video where we stopped. Alright, so we already covered the chain rule. So if we continue from the chain rule, we'll have the power rule. Alright, so for the power rule, it's actually another better way for us to differentiate the bracket with power. Like just now when we use chain rule, right, you realize that, okay the step is a bit long, which is not so convenient for us. Alright, so the power rule is the shortcut that we learned before. Okay, how to differentiate a bracket with a power. Okay, so generally when you want to differentiate any bracket with a power, what we need to do is you bring the power in front. Okay, so like what we learned before, you bring the power in front, that means you're having the n in front, copy the bracket itself, power minus 1. Alright, so you're having n minus 1. And after that, don't forget to differentiate the thing inside the bracket. So differentiate fx, you'll get f prime x at the end. Right, then you multiply all of them together to get the differentiation for this particular function. Okay, so we use this widely actually. Okay, we use it very often. Okay, so let's have a look for part A. Alright, so they want you to get the differentiation for y equals to x plus 4 power 3. So I believe that you should know how to do it. So to get the differentiation dy dx, I put the power in front, copy the bracket, power minus 1, become 2. And I differentiate the thing inside this bracket, differentiate x, I got a 1. Differentiate plus 4, you get a 0. Therefore, you're having a 1 here. So simplify your value, it should be 3x plus 4 squared. Alright, so if you compare this method with the chain rule that we discussed in the previous video or just now, you realize that, oh, this step is much more shorter. So usually in exam, we prefer this method, right? The power rule. Okay, then now we continue to part B. Okay, so for part B, if let's say they give you a function f of x equals to this, so what is the differentiation for this function? Okay, so I'm having f prime x. So again, power put it in front become 4. Power, copy the bracket, power minus 1 become 3. And after that, you differentiate the thing inside this bracket. Differentiate 3x squared, you have 3x, differentiate x power 3, you have 3x squared. After that, you try to simplify everything here. 4 times 3 is 12. So 12x squared, x power 3 plus 1 power 3. So this is what we have for applying the power rule. Alright, so I believe that you still remember all this. I hope that you still remember all this because you learned all this before. Yeah? Alright, then now we proceed further to the next page. So for all the examples that we discussed just now, we are talking about differentiation for one time only. Alright, so in our syllabus, we are actually having the higher order of derivative. Okay, so let's say when you're having f prime x is dy dx, that means you differentiate the function for the first time. And after that, from the answer that you have, if you further differentiate it, then you are having the second derivative of f. And then if you continue further, then you have the third derivative of f. And so on. Alright, so usually for our syllabus, we will cover until the third time of derivative. Second time or third time, generally. Right? Okay, so there's a small part that we need to take note of this. Okay, so when you're having d square y and dx square, please make sure that you put the square at the correct place and don't get confused with this one. When you're having dy over dx, the whole thing square, it is actually not the same as d square y dx square. So d square y dx square means that this one means that you are differentiating a function or an expression for 2 times. And it means that you are taking the square of the first derivative of the expression. So the meaning are different. Alright, so although it looks like got square, but they are totally different, 2 different things. Alright, so just make sure that you don't get confused on this part. Alright, okay, so if let's say have no problem, then we'll discuss example 4. Alright, so for example 4, you see that, okay, I'm having this equation. They want you to find out the dy dx and also the d2y dx square. Right, so first, you'll let y equals to x squared plus 2x power negative 1. I will prefer to change it become x power n before I do any differentiation. Okay, so what is dy dx here? Dy dx is 2x plus negative 1. You should copy the constant first, then the power n you put in front, and then copy the x power minus 1. You're having negative 2. So if you simplify your answer, you have 2x minus 2x negative. So this is the answer for your first differentiation. Right. Then after that, if you want to continue to get the second derivative of the equation, so start from dy dx. Differentiate 2x, you get a 2. Minus 2, you just copy it, it's a constant. So negative 2, you put in front, become negative 2 in front. X, you copy, power minus 1 become negative 3. And then you try to simplify it. And that's why your second derivative of this equation, it will be 2 plus 4 over x power 3. Alright, so this is what you have for the higher order of differentiation.